right, so we are on day 3 notes. So we do a little bit of practice. Tomorrow, we will do a little bit of a warm-up and a practice and see how the quiz at the end of the period tomorrow. Just so make sure that you know that that's going to happen. And then on Friday, we'll do something called a desktop. It's kind of fun. All right, day 3 of linear modeling. So you'll see a little bit of review at the top. We're going to find our slope using the slope formula. We've been doing this for a few units now. So I'm going to do my x1, y1, x2, y2. If you remember the slope formula, there it is. Okay, so I do my y's on top. If I match it up, that would be 8 minus -2. And my x is on the bottom, 6 minus -6. What happens when I have a double negative? Change it to addition. So that would be 10 over 12. Okay. The fraction 10 over 12, can I reduce 10 over 12? I can. 5 over 6. Okay. So we have our slope. We have our m. Okay. Does anybody remember point slope form? Everybody remember that equation? It's y minus y1 equals m x minus x minus x1. All right. We know m. What's m? Say it again. Yep. All right. So 5, 6 is our m. We don't know our y1 yet. We don't know our x1 yet. What do we fill in for x1 and y1?
Ooh. You can pick negative. You can pick one of the two.
Yeah, either point. Since I have this one already labeled x1 and y1, I'm just going to use that. So it would be y minus -2, and then x minus -6. So keep in mind, there's already a negative in the formula. So when you do it, when you have double negatives, those are going to become positive. Now, it says in the directions, write the equation as y equals mx plus b. How am I going to do that? Simplify. Distribute your 5, 6. So we'll get 5, 6x plus, and so if you do 5, 6 times 6, you should end up with 5. You can do that in your calculator. Okay, and then we'll subtract 2 from both sides. So you should end up with y equals 5, 6x plus 3. Okay, so 2 skills here. Finding slope, using point slope form, and rewriting. We're going to utilize those today. Do we have any questions before I move on? All right, what do we do when we are not given the starting amount and the rate of change? So basically, the difference between yesterday and today. Yesterday, you were given the slope and the y-intercept. Today, okay, you may be given the slope or you may have to find it, and then you're not going to be given the y-intercept, so you have to use point slope form to find that equation. All right, so first it says write your 2 order pairs and the word problem and label them, find the rate of change, and use your slope formula. So if you want to write it in right there, you can. Okay, then you're going to find your y-intercept, rewrite into point slope form. I'm sorry, from point slope form into slope intercept form, and just solve for y. We're going to be doing this process a few times today, so you'll get used to it. Okay. All right, example 1. Kirk is driving along a long road at a constant speed. So if he's going at a constant speed, what type of graph would we have? A linear graph or a straight line. He is driving directly towards Denver. He knows that after 2 hours of driving, he is 272 miles from Denver. So when we're writing our ordered pairs, 2 and 272 would be one ordered pair. 2 hours, X is time. Okay, and Y is distance in miles. Okay, what is my second coordinate point? Yeah, you read that next sentence. After 3 hours, he is 176 miles from Denver. Oh, sorry. Oh, thank you. Yeah, 3.5. So we should write that as 3.5. Not bad. All right, part B, find the average rate of change. How do we find the average rate of change? What's another word? Slope. You're going to do slope formula right here in part B. I'll let you simplify that and get what the rate of change is. All right, let's see what we end up with. Did you get negative 64? Yeah? Negative 64? Okay, so before we move on, I want you to think about what does negative 64 mean in terms of this problem. Every hour, he travels 64 miles. Okay, or you could say he's going 64 miles per hour. Now, why is it negative? Yes, he's losing distance from Denver, so he's getting closer to his destination. Okay, so we'll just make a little note of that. Now when we write our equation, we don't have the y-intercept, we don't have b, so we're going to use point slope form. So we're going to do y minus 272 equals m, which is negative 64, we just found that, and then x minus 2. I want you to go ahead and distribute and simplify and get it in y equals mx plus b form. So basically, you're going to solve for y. You're solving for y. it 400? Okay, do we agree? Does it look okay? Okay, let's break it down. Okay, the 400, we already know that the 64 is losing 64 miles per hour. We get that. What does the 400 mean?
How many is what? The distance here? The distance, sorry.
So we talked the last couple days about the y-intercept being like the starting value or the initial value. So in terms of initial value, what does 400 mean for Kirk?
Oh,
He's 400 what? Yeah, he has 400 miles for his whole trip. So when he first starts, before he even starts driving, his trip is 400 miles. Yes? Okay. So he's traveling from, he's traveling to Denver. So wherever he's starting from, okay, he's going towards Denver. Okay, why is rate of change negative? We already talked about that. He is losing miles as he drives. Okay, how far did Kirk start from Denver? 400 miles. We just discussed that as well. Ooh, I like this next question. After how many hours will Kirk arrive in Denver? How do we navigate that question? Okay, so let's think about it. We said at the beginning, y is distance. So we want his distance to be what when he arrives? 0. So we're going to take our equation up here, and we're going to set his arrival at, or his miles at 0. We'll just say it that way. And then you're basically right. We're going to end up subtracting 400 and dividing by 60. 64. My bad. Your brain's all over the place today. 6.25. 6.25 what?
hours.
Hours. Make sure you put your label on there. Okay, question, concern? Let's keep rolling. You pull out the plug from a bathtub. Okay, so imagine your bathtub is full. And you pull that plug out. After 40 seconds, there are 13 gallons of water left in the tub. Okay, so if we're going to write an ordered pair, it would be 40 seconds, comma, 13 gallons. So in this case, X is seconds and Y is gallons. Right, 1 minute after you pull the plug, there are 10 gallons left. So what's that coordinate point going to be?
1.
Not 1. Yeah. Okay, so think about it. Right, the first one was in seconds, and we just set up here X is seconds. So you have to make sure you use 60 instead of 1. A little tricky there, okay? And then 10 gallons left for that Y value. So really be careful on your labels for these. All right, in the same little area here, we're going to find the slope. Okay, so we're going to do our Y's on top, 10 minus 13. On the bottom, 60 minus 40. Ooh, I think we'll leave it like that. I don't think that we can simplify that. We'll have to leave it as negative 3 over 20. Okay, what's this mean? What's negative 3 over 20 for our slope mean in context of a bathtub draining? Okay. Okay, so let's see. What values are on top? Is it X or Y? Y on top, and Y is?
Gallon.
Okay, so it's 3 gallons per 20 seconds. So, to interpret it, the water is draining at a rate of 3 gallons every 20 seconds. Or you could say the bathtub is losing 3 gallons of water every 20 seconds. You could say it that way too. Okay, so why is it negative again? Yeah, right? We're losing water, we're not gaining water. All right, part B. Write an equation for gallons left in the tub in terms of the number of seconds. Okay, all it's saying is just write an equation. So we're going to do our point slope form. So I'm just going to use my first one, y minus 13 equals our slope, and then x minus 40. All right, I want you to distribute and simplify. Feel free to use your calculator. Kind of some rough numbers there. Do you agree with me? You get 19 for your y-intercept? No? Yes? Thank you. You're looking at me like I'm crazy. Should be 6 and then add 13, 13. Okay, so let's break it down. Right, we're talking about the slope. What does the y-intercept of 19 tell us about the bathtub? It started out with 19 gallons of water. Okay, started out with 19 gallons. All right, it says use Desmos to help with the following questions. Include units in your answers. I'm going to go ahead and pull up Desmos so you don't need to worry about it. All right, so we're putting in our equation. Maybe. All right, y equals -3 divided by 20. And we got it at 19 gallons to start. All right, now we don't see our graph. We'll probably end up using a table as my guess, but let's look at our question. How many gallons are left? Interesting. How many gallons are supposed to be left after 20 seconds? Let me go back here. Okay, we're going to add our table. Okay, and I want to know when there's 20 seconds how many gallons are left. So I'm going to put 20 in the bottom of my table. It shows me 16. So instead of plugging all of these in by hand, Desmos is really, really quick. All right. D, how many gallons are left after 50 seconds. So let me go back up here. And type in 50. Definitely not that many. All right, 11.5 gallons left. At what time will there be 7 gallons left? Now that was a little bit tougher. You can't type in Y values here. But we know that it's going to keep going down the bigger that our X values get. So let me try 60. Nope, not big enough. What about 70? 8.5. What am I looking for? 7? 80. There we go. Look at that. Okay. So I typed in 80 seconds and I got 7 gallons. So it would be 80 seconds to get down to 7 gallons. How much water did the tub have when it started draining? Yeah, 19 gallons. That was our original. Ooh, when will the water be gone? That's interesting. How can we find that? Plug 0 in for Y. So this may be a little tougher to find. You can keep guessing, but I'm going to actually use my graph feature here. I'm going to zoom out. Actually, let me zoom in a little bit. Okay, and I'm going to find the y-intercept. Okay, that is my initial value of gallons. What point on my graph will be when the water is completely drained? The x-intercept. So let's go over, keep going over, and we can actually tap right there, and it tells us it'll take about 126.7 seconds for that water to completely drain. Okay, and it was the x-intercept that we looked for.
It said slope or x.
So that was for the previous question. But on Desmos, that answer that we just got, the 126, was the x-intercept. It's the x-intercept. There's more. Okay. One more example. Okay, example 3. Water is draining out of bathtub. Again. Okay, such that the volume left gallons is shown as a function of time in minutes. So the difference between the last question and this question is we were doing gallons in seconds, now we're doing gallons in minutes. Okay, so it's a little bit different. Calculate the average rate of change over the interval of 0 to 2. So these values are x values. So I've given you the x values, you have to fill in y. Where are you going to locate the y values? In the table, right? 0.62 to 228. Okay, go ahead and do the rate of change or slope in letter A. Did you get negative 17?
Yeah.
Beautiful. All right, let's try letter B. Now, in letter B, you're using a different set of points. So you're doing 228 and 412. See if you get the same answer here. Did you get negative 8?
Yeah.
Interesting. So you remember in last unit where we found 2 slopes and we decided if it was linear or not? When was it linear? When they're the same. So this is not linear. Okay, it's not a constant average rate of change. Oops, I should have said not there. Okay, so, but in real life, I really take this back to a real life situation because that's what it is. Is this bathtub draining at a constant rate of change? No, so sometimes the water's flowing faster, sometimes it's not, sometimes it's a little bit slower. Okay, for this specific bathtub. Maybe the drain's clogged a little bit. Okay, I think the rest should be practice, yes? All right, go ahead and start working on your practice. I will